Hello everybody, welcome to the second video of AlgebraCloud, and in this video we're going to deal with powers of 10 and scientific notation. There's pretty much only 3 rules you gotta remember about this part of mathematics. You're pretty much dealing with a positive integer exponent or negative integer exponent whenever you're dealing with powers of 10. And powers of 10 are just an alternative way of pretty much simplifying very large numbers into a very condensed form. So I'll show you. We have a couple examples that we're going to do. And scientific notation, there is, I guess it's just an alternative way of writing a number that is greater than 1 or less than 1. And in this scientific notation, you use the powers of 10. So I guess we'll just do a couple examples of these and we'll go forward. Wait, let me just write down powers of 10. There you go. So you won't get confused. Okay, so in our first example, we have 10 to the 3 power. Now, if you remember that from 7.1, that 10 to the 0 power is equal to 1, then the decimal spot will be located on the right side of that right side of the 1, and right here we're just pretty much just asked to move the decimal spot three spaces to the right. So it'll be 1, 2, 3, 1, 2, 3, and it will be, our new number would be 1000. So right here would be 1,000. And an alternative way that you can check this is that when you have a number raised to a power that is positive, it also represents 10. That number times itself repeated this many times. So over here we have 10 repeating times itself 3 times. So we have 10 times 10 times 10. Okay, so you should just try and keep a thought of that. And so far powers of 10 with a positive integer are not that hard. Whatever integer it is that's positive, that's how many zeros is going to be to the right. Now when we're dealing with the left side or a negative exponent, then you're going to see that the integer moves over from the right side. 10 to the 0 is equal to 1. Notice that the decimal spot is on the right side of the 1, and now when we're going negative, we pretty much have to go to the left side. So it will be 0.1, and then we're moving over 4 spots. 1, 2, 3, 4. 1, 2, 3. Okay, so this will be our new number. Go in that direction, and we're going this direction. Okay, so we have 0.0001. And always remember that we're asked to find the value. And in our first one, we had our value to be 1000. And for our second problem for case 1, then we had our value to be 0.0001. So always try to remember that. Let's just continue on. So then, right here, we're asked to write it as, for case 2, we're asked to write it as a power of 10. Now, instead of working from 10 to standard form, so standard form meaning it's just the whole big number, how would the whole big number look like? We're going backwards now. So we're going from standard form to the powers of 10. And right here we have how many zeros? 1, 2, 3, 4. And we're looking into making it into powers of 10. So we have 10 to the power of 4. Okay? It's just that simple for when you're going from standard form to powers of 10. So our second problem for case 2 is that we have to figure out how many spaces to the left did it move. So in order to figure that out is that we have to move this decimal spot back over to where the originally was before. So we have let's just start doing our waves. And always do your waves, they're really helpful. And let's just do 1, 2, 3, 4, 5, 6. So it takes us 6 spots to the left to move back to our original spot. So always remember that's a negative since we're moving this spot over to the left, but originally we began from the left side and to the right. So now, once you understand the powers of 10, then you should be able to figure out, just a moment, just a camera position. You should be able to figure out scientific notation. And scientific notation, you only have 2 primary parts you got to deal with. You got to make sure the number in front. So you have, like our example is 2.2 times 10 to the power of 3. You got to make sure our first number here is greater than 1 but less than 10. And for our second number, you got to make sure it's in powers of 10. So in case 1, let's start working with case 1. So we're asked to find the value of an expression. In this case, we're asked 148.5 times 10 to the negative 6. Then we're asked to move the decimal spot over 6 spots to the left. So we have 148.5. Then 1, 2, 3, 4, 5, 6. We have 1, 2, 3. And that will be our value. Try writing it neater. 0.000148.5. And that will be our value that we need. Now, this one, 7.3 times 10 to the power of 3 should be fairly simple. So we just need to move over this decimal spot over 3 times. So we have 7.3, 1, 2, 3. Add zeros, and we have 7,300. Now, if you're looking for more examples, then I guess we do case 2. And in case 2, we're asked 0.07 times 10 to the negative 6. So we just move the decimal spot over 6 times to the left. So we have 0.07, 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, 5, 6 zeros to the left. And right there, our final answer would be 0.00003. 1, 2, 3, 4, 5, 6, 7. 3, 6, 7. That will be our final answer. Now, 1.23 times 10 to the negative 10 to the 4th. Then we have we just need to move over the decimal spot 4 times to the left. I mean, to 4 times to the right. So we have 1.23. And move it over to 4 spots to the right. 1, 2, 3, 4. 1, 2. Final answer would be 1, 2, 3, 0, 0. So it will be 12,300. This is pretty much it. What you're going to look for a scientific notation. You just got to be able to understand powers of 10 originally when you're dealing with negatives. So just go ahead and practice, and I'll see you in the next video.